they're not very user-friendly. If you look at the average computer game, if you look at Gran Turismo 5 compared to most CFD packages, you can tell the difference. So there's something needs to be done in terms of the actual user interface. Let's get people to get more out of the system. If they get more out of the system, it will use less energy. And then finally, the actual hardware improvements themselves. Interesting to show the picture there, but if you look at some of the current generation supercomputers, they are getting better, but there's still an awful long way to go. If you look at the amount of cooling systems that you have to go alongside the computers, it's quite fascinating. It's actually bigger than the computer itself in some cases. But there are new technologies coming along that can actually address this. We're already doing some research into the use of graphics processors for computational fluid dynamics analysis. They're 90% more efficient than a conventional computer architecture. Now, they can't be used for all of the process yet, but there are opportunities there. It's existing hardware, it's taking existing technology and putting it into a different application. So it doesn't actually require a huge amount of development, and there are a lot of opportunities like that need to be considered. Similarly, let's align the hardware to the job itself. If you look at the sort of computer architecture that you see in a big cabinet like that, it's very good at number crunching, but it's not very good at retrieving numbers from an existing data set. So why not optimize the actual computer architecture? Again, it needs research, it's not done that way at the moment. So the message I was trying to get across here is it's very easy to focus on the product itself, and some of the challenges we've got in those products are very, very significant. But don't forget the actual design process itself, because you can actually make that a lot more efficient as well. And so this comes back to how we're actually going to do that, and it was quite interesting that Jonathan this morning mentioned this idea of the R&D project of today. And one of the drivers behind CFMS was a recognition that we're not going to solve this today. I mean, this is a big problem. It's going to take us years and years and years to actually solve this. It's also important to remember, if you like, that CFMS started off effectively on the environment ticket. It came from Akari. It was around that sort of 50% fuel burn in aircraft that kicked the whole thing off. We've given ourselves 3, apologies for the sort of R&T speak, but straplines to what it is we're doing. First one is full simulation, no test. The idea there being that we want to use numerical simulation much more in the design process. So in other words, by the time you actually make the product, you've got a lot of confidence in it. Another one is an engineer as innovator, not calculator. And again, this goes back to the efficiency of the design process. If you watch a designer using most of the design tools today, it's almost painful to watch. So we need to get that process much more effective. And then finally, right first time, optimal first time. In other words, by the time you press the let's make this button, you know you've got the best product. And that needs an awful lot of work within the sort of virtual environment. So what we did was we recognized that this was going to take a long time. We set up CFMS Limited as a not-for-profit company, like was mentioned earlier. And the idea being that that company will drive forward this program of research, this not the R&D for today type activity, but it will be a sustainable program of activity. And I think it was also mentioned several times this morning, the word partnership. And I think what we've recognized within CFMS Limited is achieving this is going to be very difficult. And the only way we're going to achieve it is if people actually work together. And when we say the people working together, we've got to get the end users working with the tool developers. We've got to get the infrastructure developers working with the tool developers and the end users. And luckily within the clip art of PowerPoint, there's that cute little picture that shows people come together. But that's actually quite important. And it's important that people actually work together. And what comes from that, looking at the more business aspect of what we're trying to do, is it gives huge opportunities for an awful lot of people within the business. So the way we're trying to deliver that is we call our first activity vision realization. That's taking this rather abstract idea of this brave new world of the future and making it a bit more tangible. What we've discovered is people like something that they can actually relate to, and a rather abstract long-term vision is very difficult for most people. And then finally, we're going to try and encourage research. So this idea of facilitating actual research but not just the research, but how does it actually get deployed? Because it's all well and good doing a lot of research, but unless it actually gets put into business, there's no point in doing it. And then finally, we're going to provide facilities to actually support that. So organisations, small organisations or larger organisations, that can't get access to the technology to actually try some of these tools and processes, we will actually provide a facility there for them that will enable the wider community to get involved. So this is the way we see the way forward. The bottom line is this low carbon world that we've heard a lot about today, it will be dependent, and the word there is dependent, it's not just going to happen by itself, on delivering products and services that actually meet very, very challenging targets. The sort of targets that we've just heard about, some of these numbers were a bit scary, and I'm glad I live on a hill having seen all the flooding pictures there. But the bottom line is these are very ambitious targets, and we will need tools and services if we're going to achieve them. I don't want to put down the tools that people use today. Effectively, the computational fluid dynamics that Met Office uses is actually very good. They are very capable. But the bottom line is, we need much more powerful tools if we're actually going to simulate the entire design space. I think it was used again earlier on this morning. I think it was Andrew that said we needed a big change. What we say is paradigm shift. The bottom line is we're not looking at an incremental improvement in terms of things. It's too late for that. We've got to look at a massive change in the power of these. The phrase we've coined is a 10 to the 6th power improvement. You can argue whether it should be 10 to the 5th, 10 to the 7th, but the point we're trying to make is an incremental improvement in these simulation tools isn't enough. We've got to look at a complete transformation of how we do that. But what goes with that is a huge opportunity, because the people that actually develop these tools, there is a massive business opportunity there. But also the people that learn how to apply those tools, there's a huge opportunity there as well. And we saw examples this morning of companies that are coming up with new products that are a huge opportunity for the future. And if you can get access to the right tools and also develop those right tools, it will give you a huge competitive edge. And then finally, as a little plug, that CFMS as an organisation is going to have a go at trying to support that vision as well.